क्लास 10th केमिस्ट्री की चैप्टर नंबर 3 मेटल्स एंड नॉन मेटल्स के नोट्स हैं ये वेरी इंपॉर्टेंट नोट्स. On the basis of their properties, all elements can be divided into two groups, metals and non-metals. Malleable. The properties of metal by which we can beat the metal with hammer in the form of thin sheets is called malleability and the matter is called malleable. Ductile. The property of matter by which we can make the metals in form of wire is called ductility and the matter is called ductile. Brittle. If the matter break into piece, if we hammered on stretched, this property of matter is called brittleness and the matter is called brittle. Metal. Metals are elements that conduct heat and electricity and are malleable and ductile. For example, iron, aluminium, copper, etc. Metals form positive ion by losing electrons. Non-metals. Non-metals are the elements that do not conduct heat and electricity and are neither malleable nor ductile. For example, carbon, sulfur, oxygen, etc. Non-metals are the elements which form negative ions by gaining electrons. Physical properties of metal. Metals are malleable, metals are ductile, metals are good conductor of heat, metals are good conductor of electricity, metals are lustrous, metals are generally hard, metals are strong, metals are solid at room temperature, metals have high melting point and boiling point, metals have high density, metals are sonorous, metals generally have silver or grey color. Physical properties of non-metals. Non-metals are neither malleable nor ductile. Non-metals do not conduct heat and electricity. Non-metals are not lustrous, they are dull. Non-metals are generally soft. Non-metals are not strong. Non-metals may be solid, liquid or gas at room temperature. They have comparatively low melting and boiling point. Non-metals have low density. Non-metals are not sonorous. Non-metals have many different colors. Exceptions. Carbon is a non-metal which conducts electricity. Iodine is non-metal which is lustrous, having a shiny surface. Alkali metals such as lithium, sodium and potassium are soft, whereas carbon in the form of diamond is extremely hard. Mercury metal is liquid at room temperature. Some metals like sodium and potassium have low melting points, but diamond have very high melting and boiling point. Alkali metal like lithium, sodium, potassium are exceptional. They have low density. Chemical properties of metal. Reaction of metal with oxygen. Metal reacts with oxygen gives us metal oxides. When metal reacts with oxygen, they form metal oxides. Metal oxide is basic in nature. For example, when sodium reacts with oxygen at room temperature, they form sodium oxide. 4Na plus O2 gives us 2Na2O. Most of the metal oxide are insoluble in water, but some metal oxide dissolve to form alkalis. For examples, Na2O plus H2O gives us 2NaOH. Reaction of metal with water. Metals react with water to form a metal hydroxide and hydrogen gas. Metal plus water gives us metal hydroxide plus hydrogen. For example, potassium reacts with water, it forms potassium hydroxide and hydrogen gas. 2K plus 2H2O gives us 2KOH plus H2 plus heat. Reaction of metal with dilute acid. When metal reacts with dilute acid, they form metal salt and hydrogen. Metal plus dilute acid gives us metal salt plus hydrogen. For example, sodium metal reacts with dilute hydrochloric acid to form sodium chloride and hydrogen. 2Na plus 2HCl gives us 2NaCl plus H2. The reactivity or activity series. The arrangement of metal in vertical column in the order of decreasing reactivities is called reactivity series of metal. Potassium, sodium, calcium, magnesium, aluminum, zinc, iron, tin, lead, hydrogen, copper, mercury, silver, gold. Those metals which can lose electron more rapidly than hydrogen are said to be more reactive than hydrogen, and which lose electron less rapidly than hydrogen are said to be less reactive. Reaction of metal with salt solution. Salt solution of metal B plus metal A gives us salt solution of metal A plus metal B. For example, reaction of zinc with copper sulfate solution. Copper sulfate plus zinc, zinc sulfate plus copper. Reaction of metal with chlorine. Metal reacts with chlorine to form ionic chloride. For example, 2Na plus Cl2 gives us 2NaCl. Calcium plus chlorine gives us calcium chloride. Reaction of metal with hydrogen. When metal reacts with hydrogen, it forms metal hydride. Metal plus hydrogen gives us metal hydride. 2Na plus H2, 2NaH. Chemical properties of nonmetals. Reaction of nonmetals with oxygen. The nonmetal react with oxygen to form acetic oxide or neutral oxide. That is C plus O2 gives us CO2. 2C plus O2 gives us 2CO. Reaction of nonmetals with water. Nonmetals do not react with water or steam to evolve hydrogen gas. Reaction of nonmetal with dilute acid. Nonmetals do not react with dilute acid. Reaction of nonmetals with salt solution. A more reactive nonmetal displaces a less reactive nonmetal from its salt solution. 2NaBr plus Cl2 gives us 2NaCl plus Br2. Reaction of nonmetals with chlorine. Nonmetals react with chlorine to form covalent chlorides which are non-electrolytes and do not conduct electricity. Hydrogen plus chlorine gives us 2HCl. Reaction of nonmetal with hydrogen. Nonmetal react with hydrogen to form covalent hydrides. For example, H2 plus S, H2S. वो काट रहे हैं. Uses of metal. Iron, copper and aluminum metal are used to make hydrogen household utensils and factory equipments. Lead metal is used in making car batteries. The liquid metal mercury is used in making thermometers. Zinc is used for galvanizing iron to protect it from rusting. Copper and aluminum metal are used to make wires to carry electric current. Uses of nonmetals. Liquid hydrogen is used as a rocket fuel. Compound of nitrogen like trinitrogen toluene TNT is used as explosive. Sulfur is used as fungicides and in making gunpowder. Due to inertness, nitrogen is used to preserve food material. Noble gases or inert gases. Those gases which have 8 electrons in outermost shell are called noble gases. They are very much stable and do not take part in reaction. Except helium is a noble gas having 2 electrons in outermost shell. The various noble gases are helium, neon, argon, krypton, neon, radon. Causes of chemical bonding or chemical combination. The atoms combine with one another to achieve the inert gas electron configuration. An atom can achieve the gas configuration by 3 ways: by losing electrons, by gaining electrons, by sharing electrons. Ions. An ion is an electrically charged atom which is formed by gaining or losing electrons. These are two types of ion: cation or anion. Cations contain less electrons than normal atom, that is, number of electrons is less than number of protons, and anions contain electrons having normal atom, that is, number of electrons are greater than number of protons. Cations are positively species whereas anions are negatively species. Formation of positive ions. If there are 1, 2 or 3 electrons in outermost shell, then it loses electron to achieve the electronic configuration of nearest inert gas and acquires +1, +2, +3 charge respectively. For example, sodium Na+, magnesium ion Mg+2, aluminum ion Al3Cl3. Formation of negative ion. If an element has 5, 6, 7 electrons in an outermost shell, then it acquires -3, -2 or -1 charge respectively to gain the configuration of nearest inert gas. For example, chlorine ion Cl-, oxide ion O2-, nitride ion N3-. Types of chemical bond. There are two types of bond: ionic bond, covalent bond. Ionic bond. The chemical bond formed by the transfer of electrons are called ionic bond. These form when one atom wants to donate the electron and other electrons to achieve inert gas electronic configuration. In ionic bonds, there is a strong force of attraction developed between the opposite charge ion. For example, formation of sodium chloride. Na plus electron gives us sodium plus ion. Chlorine plus electron gives us Cl minus ion. Sodium plus chlorine gives us sodium chloride. Similarly, formation of magnesium chloride. Mg plus Cl2, Cl gives us MgCl2. Note, the compound containing ionic bonds are called ionic compounds. Covalent bond. The bond formed by sharing of electrons between two atoms is known as covalent bond. Covalent bonds are of three types: single bond, double bond, triple bond. Single bond. The covalent bond formed by sharing of one electron by each atom is called single bond. For example, formation of chlorine molecules shown in figure. Formation of hydrogen molecule, formation of hydrogen chloride molecule. Double bond. The covalent bond formed by sharing of two electrons by each atom is called double bond. For example, formation of oxygen molecule shown in figure. Formation of carbon dioxide molecule, formation of ethene molecule. Triple bond. The covalent bond formed by sharing of 3 electrons by each other atom is called triple bond. For example, formation of nitrogen molecule N2. As shown in figure, formation of ethyl molecule C2H2. Covalent compound. The compound containing covalent bond are known as covalent compound. Covalent compounds are formed by sharing of electrons between atoms. Properties of ionic compound. Ionic compounds are usually crystalline solids. Ionic compounds are highly melting and boiling point. Ionic compounds are usually soluble in water but insoluble in organic solvents. Ionic compounds conduct electricity when dissolved in water. Properties of covalent compound. Covalent compounds are usually liquid or gas. They have low melting and boiling point. They are usually insoluble in water. They do not conduct electricity. Aqua regia. Aqua regia is a fresh prepared mixture of 1 part of concentrated nitric acid and 3 part of concentrated hydrochloric acid. It can dissolve all metal. It can also dissolve gold and platinum metal. Minerals. The natural material in which the metal or their compounds are found in earth are called minerals. Ores. Those minerals from which the metals can be extracted conveniently and profitably are called ores. Extraction of metal. To obtain a metal from a ore is called extraction of metal. Gangue. The unwanted impurity like sand, rocky material, earthy particles, limestone, etc. present in an ore are called gangue. Extraction of high reactive metal. The highly reactive metals are extracted by the electrolytic reduction of their molten chloride or oxides. Extraction of sodium metal. Sodium metal is extracted by the electrolysis reduction of molten sodium chloride. When electric current is passed through molten sodium chloride, it decomposes to form sodium metal and chlorine gas. 2NaCl electrolysis gives us 2Na plus Cl2. Extraction of aluminum metal. Aluminum metal is extracted by the electrolysis reduction of molten ammonium chloride. When electric current is passed through molten aluminum oxide, it decomposes to form aluminum metal and oxygen gas. 2Al2O3 electrolysis gives 4Al plus 3O2. Extraction of moderated reactive metal. The moderated reactive metal, which are in the middle of the reactivity series, are extracted by the reduction of their oxide with carbon, aluminum, sodium and calcium. It is easier to obtain metals from their oxide. The process used are calcination or roasting. Calcination. Calcination is the process in which a carbonate ore is heated strongly in the absence of air to convert it into metal oxide. For example, zinc carbonate gives us zinc oxide plus carbon dioxide. Roasting. Roasting is the process in which a sulfide ore is strongly heated in the presence of air to convert it into metal oxide. For example, zinc sulfide reacts with oxygen, gives us zinc oxide and sulfur dioxide. Extraction of less reactive metals. The less reactive metals, which are quite low in activity series, are extracted by the reduction of their oxide by heat alone. Extraction of mercury. Mercury metal can be extracted just by heating a sulfide ore in air. For example, 2HGS plus 3O2 on roasting gives us 2HGO plus SO2. Extraction of copper. It can be extracted just by heating a sulfide ore in air. 2Cu2S plus 3O2 gives us 2Cu2OS plus 2SO2. Refining of metal. The process of purifying impure metals is called refining of metals. Refining of impure metal is generally done by electrolysis refining. Corrosion. The heating up of metal by the action of air, moisture or a chemical on their surface is called corrosion. Corrosion of iron is called rusting. Rusting of iron. When an object is left in damp air for a considerable time, it gets covered with a red browny flaky substance called rust, and the process is called rusting of iron. For example, for rusting, presence of air, oxygen and presence of water, moisture is necessary. Method of preventing iron from rusting. The various methods are as follows: by painting, applying grease or oil, by galvanization, by tin plating or chromium plating, by alloying it to make stainless steel. Alloy. An alloy is a homogeneous mixture of two or more metals. It is prepared by mixing various metals in molten states. The property of an alloy is different from the property of its pure metal. Various alloy. Various alloy are as follows: brass alloy of copper and zinc, 80% copper and 20% zinc, used for fancy lamps. Bronze alloy of copper and tin. 90% copper and 10% tin. Used for utensil and ships. Solder, alloy of lead and tin, 50% lead and 50% tin. Used for soldering. Amalgam, alloy of mercury or silver, tin and zinc, used by dentists for filling. Alloy of gold. The purity of gold is expressed in terms of carats. Pure gold is said to be 24 carat. Gold ornaments are usually made of 22 carats. It means 22 part pure gold is alloyed with 2 part of either silver or copper. That's all in this video.